Good morning, students. I am Dr.R.SUGANYA, Assistant Professor, Department of Computer Science with Cybersecurity. Today we are going to see about key management. Key management. One of the major roles of public key encryption has been to address the problem key of key distribution. So the main thing is key distribution. So there are actually two distinct aspects to the use of public key cryptography. So this distribution of public keys means like to distribute secret keys. Distribution of public keys have several techniques that have been proposed for the public keys. So virtually all the proposals can be grouped into following general schemes like public announcement, publicly available directory, public authority of public key certificates. Public announcement of public keys. On the face of it, this point of public key encryption is a public key, and thus if there is some broadly accepted public key algorithm such as RSA, any participant can send his or her public key to any other participant or broadcast the key to the community. For example, because of the growing popularity of PGP, which makes use of RSA, many PGP users have adopted the practice of appending their public key to messages that they send to public forums such as Usenet news groups and internet mailing lists. Here we can see A and B and there are two keys here, and we have the operations, how the source is being sent to destination. So although this approach is convenient, it has a major weakness. Anyone can force such as a public announcement. Some user can pretend to be user A and send a public key to another participant or broadcast such a public key. So until such time as user A discovers a forgery and alerts other participants to read all encrypted messages. Publicly available directory. A greater degree of security can be achieved by maintaining a publicly available dynamic directory of public keys. Maintenance and distributions of public directory would have to be the responsibility of some trusted entity or organization. Such a scheme would include the following elements. The authority maintains a directory with the name, public key, entry for each participant. Each participant registers a public key with the directory authority. Registrations would have to be in person or by some form of secure authenticated communication. A participant may replace the existing key with a new one at any time, either because of the desire to replace a public key that has already been used for a large amount of data, or because a corresponding private key has been compromised in some way. Participant could also access a directory electronically. For this purpose, secure authenticated communication from the authority to the participant is mandatory. Here is we have a public key publications like A and B. So we have a directory for both source and destination. So this scheme is clearly more secure than individual public announcement, but still has vulnerabilities. If an adversary succeeds in obtaining the private key of directory authority, the adversary could authoritatively pass out counterfeit public keys and subsequently impersonate any participant and eavesdrop on messages sent to any participant. In another way to achieve the same and is for of adversary to tamper with the records kept by the authority. Next is public key authority. Stronger security for public key distributions can be achieved by providing the tighter control over the distribution of public keys from the directory. A typical scenario is being illustrated, which is based on POP 79. As before, the scenario assumes that a central authority maintains a dynamic directory of public keys of all participants. In addition, each participant reliably knows a public key for the authority, with only the authority knowing the corresponding private key. A sends a time-stamped message to the public key authority containing a request for the current public key of B. The authority responds with a message that is encrypted using the authority's private key, and thus A is able to decrypt the message using the authority's public key. Therefore, A is assured that the message is originated with the authority. The message includes the following: B's public key, pub, which A can use to encrypt the message destined for B. The original request to enable A to match this response with the corresponding earlier request and to verify that the original request was not altered before the reception by the authority. The original timestamp So A can determine that this is not an old message from the authority containing a key other than B's current public key. A stores B's public key and also it uses to encrypt the message to B containing an identifier of A. So here B retrieves A's public key from authority. So and B sends a message to A encrypted with PU and containing A's none as well as a new one generated by B. Because only B could have decrypted the message. The presence of N1 in a message assures A that correspondent is B. So A return N2 and encrypted using B's public key to assure B that its correspondent is A. So here we can see the scenario of public key distribution. So how it has been the initiator which requests for the public key and how it has been responding. So a total of 7 messages are required here. So however, the 4 messages needs to be used only infrequently because both A and B can save the other's public key for future use, which is a technique known as caching. Periodically, a user should request fresh copies of public key of its correspondence to ensure the accuracy. Public key certificates. So here it has drawbacks like it will be like a bottleneck in the system for a user which must appeal to the authority for a public key for every other user that it wishes to contact. So as before, the directory of names and public keys maintained by the authority, it is vulnerable to tampering. So certificate consists of public key plus an identifier of the key owner with the whole block signed by a trusted third party. So we can place the following requirement like any participant can read a certificate to determine the name and public key of the certificate's owner. Any participant can verify that the certificate originated from the certificate authority and is not counterfeit. Only the certificate authority can create and update certificates. These requirements are satisfied by the original proposal. So any participant can verify the currency of the certificate. A certificate scheme is illustrated here. So certificate authority AB, which has been requesting for both sending and receiving. So how it is being followed from a certificate authority to the first party and second party. So here application must be in person and it is authenticated. So the timestamp also validates the current of the certificates. So if the certificate is sufficiently old, it is assumed to be expired. So one scheme has become universally accepted for formatting the public key certificates. So X.509 and certificates are used in most network security applications including IP security, secure socket layer and secure electronic transactions and MIME. So there are some questions. What is the primary purpose of key management? In symmetric key management, how is a key shared between sender and receiver? Which of the following is not a method of key distribution? Which of the following is a key management challenge in asymmetric cryptography? In a public key infrastructure, what is the role of certificate authority? And which of the following key management system is designed to generate and manage symmetric keys? What is a term for a temporary key that is used for single communication session? What is a keys scroll in cryptographic key management? Which of the following used to update cryptographic keys periodically enhance security? In key management, what is key revocation? Thank you.